Hi friends, my name is Srinivas, known to be BS Rao. You are watching wonderful online platform C level physics meant for foundation level cbse, icse, igcse, neet, JEE, main and advanced aspirants. I will try my level best in producing best concepts with best illustrations. So please subscribe channel C level physics. Okay, today I came up with the wonderful topic that is rain umbrella sums. Right here. Some alphabets are written right on the top here, which we are going to use in this topic. See, R means rain, M stands for man, VR means velocity of rain with respect to ground. So velocity of rain with respect to ground means velocity of any body with respect to ground, that is absolute velocity. So here VR or VRG both one and the same, means velocity of rain with respect to ground, that is absolute velocity of rain. Next, Vm means velocity of man with respect to ground. So velocity of man with respect to ground means absolute velocity of man. Similarly here Vrm means relative velocity of rain with respect to man. See, velocity of rain with respect to man means it's not absolute, that is velocity of rain as measured by man. Right? If someone walks on the rainy day with umbrella, he must hold his umbrella in a direction relative velocity of rain with respect to himself. Right? If you want to keep the rain away, he must hold his umbrella in the line of relative velocity of rain with respect to himself. Okay. Now let us see best examples in this topic. Okay. Now see, in example 1, here see, a man is standing on the ground, means velocity of man with respect to ground, that is 0, means he is stationary. He is not at all moving. Now with respect to the stationary man, rain falling vertically downwards like. See, rain falling vertically downwards. See, this what? R stands for rain. So VRG, velocity of rain with respect to ground. That is absolute velocity of rain. That is what? As an example, 20 kmph. Right? Now, if he wants to keep the rain away, in which direction he has to hold his umbrella? Let us check. Right? As I told you, he must hold his umbrella in the direction of relative velocity of rain with respect to himself, with respect to man. Okay, now let us see. Now, what is the relative velocity of rain with respect to man? By definition itself, Vrm bar equal to Vr bar minus Vm bar. Okay, Vr bar minus Vm bar by definition. That also can be written as Vr means Vrg, Vrg bar minus Vm means plus of minus Vmg bar. Why? Because there is no direct subtraction in vectors. Subtraction also one kind of addition, as I told you in the previous classes. So here minus Vm means plus of minus Vmg, means addition of velocity of man with respect to ground to velocity of rain with respect to ground. That's all. Right? So this is what Vrg means. What is Vrg here? Vrg means 20. What is the direction of Vrg here? Vertically downwards. What is unit vector along vertically downwards? Minus I cap. That is 20 into minus j cap, negative y-axis, minus j cap, plus what is Vmg? Vmg means 0. That is ultimately final answer is Vrm is minus 20j. So what is the relative velocity of rain with respect to man? That is minus 20j. So he must hold his umbrella along the same line of Vrm, but opposite to this vector. Why? Because here this is horizontal. Now we got relative velocity of rain with respect to man, that is minus VRM bar equal to minus 20 J cap, right? Minus 20 J cap. So he must hold his umbrella as shown. He must hold his umbrella along the same line of VRM, but in opposite direction. Why? Because VRM is vertically downwards, but here umbrella opens to higher like that, along positive y-axis. Okay, along positive y-axis. So this is what VRM, relative velocity of ray with respect to man, right? Now in example 2, this time velocity of man with respect to ground is not equal to 0. That is 15 kmph. 15 kmph. Alright? So velocity of man with respect to ground is 15 kmph. The velocity of rain is vertically downwards, that is 20 kmph. So by definition, so as usual, VRM is equal to VR bar minus VM bar, that is equal to VRG plus or minus VMG bar. That is equal to VRG means minus, that is 20 into minus J cap plus of minus VMG means, what is VMG? 15 kmph, that is along positive, what is the direction here? Positive x-axis, VMG. So plus or minus 15 I cap. See, what is the direction of motion of man here? Along positive x-axis, that is plus or minus VMG means 15 I cap, as it is positive x direction. Okay, so that is equal to minus 20J minus 15 I cap. See, velocity of rain with respect to man has two components, that is x component negative, y component also negative. If x and y are both negative, we came to know that the direction, the vector VRM lies in third quadrant, not along y direction, not along the negative y direction, but along which direction? See like that. Okay. Now what is the direction of VMG? This is what in fact VMG. Now what is minus VMG? Simply make it reverse VMG. That is minus VMG bar. Alright. Now what is the direction of VRM means? Minus 20J minus 15I means definitely that is third quadrant. So this is what third quadrant. First to second to third. This is what VRM. VRM bar. Right? VRM bar. Okay. So here VRG vertically downwards. VRG vertically downwards. Right? So VMG along positive x minus VMG along negative x. VRG vertically downwards. See, this is the VRM is the resultant of VR and minus VM. So VR minus VM. So both collectively form this VRM. So this is what VRM is the resultant of VRG and minus VMG. So if I close other two sides to have parallelogram like that. So this is the parallelogram. See, these two are parent vectors which are drawn from the same point and taken as the adjacent sides of parallelogram. Then diagonal drawn from the same common point is the resultant. See, this is what resultant. What is that resultant? Relative velocity of rain with respect to man, VR. Right? Here we can say the direction of VRM by taking angle either with vertical, otherwise horizontal. Here also you can say. Right? Here also you can say, otherwise here also you can say. I am interested in taking with vertical. See, theta is taken with vertical. Right? Lower vertical. Now, see, he must hold his umbrella to keep the rain away along the same line of VRM but opposite to VRM. See, this is what VRM, this is what opposite to VRM. So he has to hold his umbrella like that. Right? He has to hold his umbrella like that. Right? If it is theta, this is also theta. By making some angle theta with vertical. See, this is what umbrella. The position of umbrella. So if you want to keep the rain away, he must hold his umbrella such that making an angle theta with vertical. Why? Because VRM is in the third quadrant. See, the umbrella also positioned along the same line but opposite to VR. Opposite to VR, like that. See, this is what, this is the position, proper position of the umbrella to be held, right? To protect himself from the rain. Okay, this is the position, correct position. While walking with 15 km/h on horizontal road, right? For a given velocity of rain with respect to ground 20 km/h. Okay. What is the direction of air? Means take tan theta. So tan theta equal to what is tan theta? Opposite side by adjacent side. Opposite means what is this side? That is minus VMG in fact, but magnitude VMG only. That is VMG divided by adjacent. What is adjacent here? VRG bar. That is magnitude VRG. See once again, from this right angle triangle, tan theta equal opposite side by adjacent side. Opposite. What is present in opposite? That is minus VMG bar. What is the magnitude? VMG. So opposite VMG by adjacent VRG. Now what is VMG? Velocity of man with respect to ground. That is 15 divided by 15 km/h divided by VRG. Velocity of rain with respect to ground 20, right? 15 km/h by 20 km/h. That is 3 by 4. 3 by 4. Now theta equal to tan inverse 3 by 4. That equal to tan 37 equal to 3 by 4. 3 by 4. See, we have basic right angle triangle with vertex angles 37, 53, 90. Right? So in some sums, you won't be given a tan 37, sin 37, cos 37. We have to familiar with the triangle, proper right angle triangle. See, with vertex angles 37, 53, 90 degrees. Now tan 37 equal to 3 by 4. See, this is 3. This is what? 5. Hypotenuse 5. Why? Because root over 3 square plus 4 square equal to hypotenuse. That is hypotenuse equal to root over 3 square plus 4 square, which is equal to root 25. That is 5. See here, from this right angle triangle, if it is 37 degrees, this must be 53. This is 9 degrees. So therefore, tan 37 equal to 3 by 4. 3 by 4. That is 3 by 4 means tan 37. So theta equal to 37 degrees. 37 degrees. So this is the direction along which he must hold his umbrella if he wants to keep the rain away. Right? Now in example 3, this time rain falling vertically downwards with 20 km/h as usual. There is no change. V or G, velocity of rain with respect to ground, that is 20 km/h vertically downwards. But as far as man is concerned, this time the speed of man increased from 15 km/h to 20 km/h. Right? So man, what is VMG, velocity of man with respect to ground? That is equal to 20 km/h. 20 km/h. See, velocity of man with respect to ground along positive x-axis at 20 km/h. Velocity of rain with respect to ground vertically downwards. As usual, VRM. What is VRM here? VRM bar equal to VR bar minus VM bar. That also equal to VRG bar plus or minus VMG bar. Right? VR means VRG. Minus means plus or minus. VM means VMG. Velocity of man with respect to ground. Now see, what is the velocity of rain with respect to ground here at 20 km/h vertically downwards? Means Vertically downwards means what is the unit vector? Minus j cap. That is minus 20 j cap. Plus or minus VMG. VMG means 20 kmh along positive x means I cap plus I cap. So plus or minus VMG means 20 I cap. 20. This time also VRM has two components, x component and y component. Both are of same magnitude, but see the unit vectors here minus j cap, here also minus I cap. Means again VRM lies in third quadrant as in the previous case. Right? That is 20 minus 20j minus 20i. Right? Now let us continue. See here. Right, this is what vertical, this is what velocity of man with respect to ground. Velocity of man with respect to ground. In fact, along positive x. Now, simply make it reverse VMG to have minus VMG. On making reversal here, we have minus VMG bar, right, along negative x-axis. Now see, VRG is vertically downwards. VRG vertically downwards. Okay, right? Now VRM lying in the third quadrant. How can you say? Means here both x component negative, y component also negative. Means unit vector, both unit vectors negative 1. Minus I cap minus j cap. So we came to know that this vector must lie in between these two parent vectors such that lying in third quadrant. Line once again. So this is what V R M bar, velocity of rain with respect to man, right? He is not at all stationary, he is under motion. Therefore, this is what, it's not absolute velocity of rain, that is relative velocity of rain with respect to moving man, right? Again, I am taking angle somewhere here with vertical. Of course, we can take with horizontal also, here also, but I am taking with vertical. So on closing two sides here, we can have parallelogram like that. Means VRM is the resultant of these two parent vectors. See, these two parent vectors collectively forming VRM bar. VRG bar plus or minus VMG bar. Means the addition of VRG bar and minus VMG bar collectively forming VRM bar. So this is the resultant of these two parent vectors. Right? Now, what is the direction? What is the direction in which umbrella is to be held if he wants to keep the rain away? Means, see, this is what VRM. Definitely, he must hold umbrella along the same line but opposite to VRM. Like, see, this is what theta. These two vertically opposite angles. So he must hold his umbrella like that. Right? In the same direction. Okay. Now, what is the tan theta here? If you are asked to determine the direction, you must find theta. So tan theta again equal opposite side by adjacent side. What is opposite here? Opposite means minus VMG bar is there, but take magnitude only. That is VMG. Opposite means VMG. I am taking magnitude VMG divided by adjacent means adjacent side VRG. Right? That is VMG. What is VMG? 20 kmph. 20 divided by VRG means again 20. That is 20 by 20. 20 kmph by 20. That is tan theta equal to 1. Theta must be equal to 45 degrees. Right? So tan theta 1 means theta 45. So this is the direction, right, in which you must hold this umbrella. Means umbrella is to be held such that making an angle 45 with upper vertical, right? Of course, it is along the same line of VRM but opposite to VRM. Why? Because VRM is along this way, umbrella is opened along that way, but same line. Okay, right? But here one important point worth note means See, in both cases, in both sums, velocity of rain with respect to ground is same. Here also 20 kmph, here also 20 kmph, direction also same, vertically downwards. Here, in first example, that is in second example, velocity of man with respect to ground is 15 kmph rightwards along positive x-axis. Here also, here the velocity of man with respect to ground increased from 15 kmph to 20 kmph along same way, right? Right. Here one more point here. Rain is falling vertically downwards in both cases of same magnitude, 20 kmph. See the directions here. In second case, if this is theta 1, for example, what is theta 1? Theta 1, theta 1, theta 1 equal 37 degrees. In second example, let be theta 2, that is theta 2 equal to 45 degrees. 45 degrees means angle is somewhat increased from 37 degrees to 45 degrees. What is the inference here? Means, what is the inference? For a given vertical velocity of, rain, for a given vertical velocity of rain means, for a given constant velocity of rain, means in both cases velocity of rain is same, direction also same. So what I am saying, for a given vertical velocity of rain, if the speed of man with respect to ground increases, then theta means that is making by umbrella with vertical also is to be increased. See here, in first case 37, here 45 degrees means theta also is to be increased. Means in first case, when he is walking at 15 kmph, so he hold his umbrella such that making an angle 37 with vertical, right? When he speeds up from 15 kmph to 20 kmph like that, so he has to slant, the umbrella has to be slanted furthermore from the vertical, means 37 to 45. Initially 37, now 45. See once again the same point. For a given vertical velocity of rain, if the velocity of man with respect to ground increases along horizontal, right, then the angle, then the umbrella also is to be slanted furthermore from the vertical, if he wants to keep the rain away, right? So in first case 15 kmph, in second case 20 kmph. So in first case, this is the position of the umbrella if he wants to keep the rain away, thus that making an angle 37. Now in second case, as velocity increased from 15 to 20 kmph, so he has to tilt the umbrella furthermore in the same plane, right, like that, from 37 to 45. So what is the inference here? Means for a given vertical velocity of rain, if the velocity of man along horizontal increases, right, he must hold his umbrella, or he must tilt his umbrella away from the normal in the same plane, right? That is the inference. So same can be writing somewhere here. Same can be written somewhere here. Suppose is what man is running, velocity of man increasing, right? Here angle made by umbrella also to be increased. See, as velocity man increases along horizontal, then the angle made by umbrella with vertical also increases. That is the inference, right? Next example, that is number 4. Example number 4. In example number 4, let us see. This time, rain is not at all falling vertically downwards, right? Rain falling at slanted with the vertical or horizontal, right? See number 4, example 4. Here this is what horizontal. Here rain is falling like that. Velocity of rain with respect to ground. What is the speed? 50 kmph. Right? So this is what rain. So what is the angle made by rain with horizontal means that is 37 degrees, right? Here a man is running along positive x-axis on the horizontal with a speed Vm g, velocity of man with respect to ground, that is equal to 40 kmph. 40 kmph, right? See, this time rain is falling such that making an angle 37 degrees with the horizontal. See, this is what horizontal, this is what horizontal. But here, man is running on the same horizontal with a speed of 40 kmph, that is towards positive x-axis, right? Now, how he would protect from the rain, let us see. See here, as velocity of rain with respect to ground is making some angle with some angle with horizontal, it can be split up into two components, that is along horizontal and along vertical, like that, right? So what is the component here? This must be opposite side. This is adjacent side. On closing like that. This is opposite. This is adjacent. Now what is adjacent component here? 50 cos 37. 50 cos 37. That is 50 into cos 37. See here. Cos 37 means adjacent side by hypotenuse. That is 4 by 5. 4 by 5. So that is 50 by 5 means 10. 10 into 4. 40 kmph. 40 kmph. Right? 40 kmph. This is what component of velocity of rain with respect to ground along horizontal. Now let us see vertical component. So this is what, this must be opposite side. This is also opposite side. Means 50 sin 37. 50 sin 37 degrees. That is 50 into sin 37. Sin 37. See here, sin 37 opposite side by hypotenuse. That is 3 by 5. So 3 by 5. 50 by 5. 10. 10 into 3. 30 kmph. 30 kmph, right? So velocity of rain with respect to ground, VRG can be written as 40 into I cap minus 30 into j cap. See, this is along positive x-axis. This component is along negative axis. So 40 into I cap minus 30 into j cap. Minus 30 into j cap, right? Okay, now let us see the direction of VR. So V or m bar, that is equal to velocity of rain with respect to man. Velocity of rain with respect to man. That is VR bar minus Vm bar. That also equal to VRG bar plus or minus Vmg bar. Right? That is VRG. What is VRG? 40i minus 30j. So 40i minus 30j plus or minus, minus is common, Vmg. Vmg means 40. 40 I cap along positive x-axis. Positive x-axis, that is minus 40. Plus or minus, minus Vmg is 40 I cap. So plus 40 minus 40 cancel. We left with minus 30j. Minus 30j. Minus 30j. See, that the vector Vrm is equal to minus 30j. So there is no x component. It has only y component, that too along negative y-axis. Negative y-axis. So see, this is horizontal. This is the direction of velocity of rain with respect to man. Velocity of rain with respect to man. Right? It is what? Minus 30 j cap. Minus 30 j cap. Right? Now see, Vmg is along positive x-axis. Vmg, positive x-axis, that is 40 kmph, right? Now make it reverse Vmg to have minus Vmg bar, right? Now see here, both minus mg and Vrg collectively forming Vr. So Vrm is the resultant of these two vectors, Vrg and minus Vmg, minus mg. So Vrm and minus Vmg collectively forming Vr. So Vrm multiply between these two vectors, right? like that. So this is what V R M. Sorry. So VRM means minus 30J. VMG minus VRM equal to minus VMG VRG. What is VRG? Sorry, VRG is this is the VRG. Sorry, this is what VRG. This is what VRG. See, once again, VRG is 50 kmph in the fourth quadrant. See the presence of VRG. That lying in fourth quadrant, right? VRG, right? So VRM is the resultant of VRG and minus VMG. See these two parent vectors. VRM is the resultant of these two parent vectors. Now form parallel to this side. I am taking like that, right? Okay, parallel to this side. So this is what VRG, right? See, VRM is the resultant of these two parent vectors, right? These two parent vectors forming VRM. See, this is the diagonal passing through the same common point, right? Same common point. Okay. Now you must hold his umbrella like that, right? For the given velocity of rain, such that making 37 degrees with the horizontal. For this man who is running at 40 kmph along positive x-axis on the horizontal, then you must hold his umbrella along vertically up. Why? Because VRM is vertically downwards. So you must hold his umbrella along the same line but opposite to VRM line. See, this is the correct position of the umbrella for this man who is running at 40 kmph. Right? Okay, this is the correct position. Vertically up. Right? Vertically up. Now, of course, here, this is the resultant of these two vectors. Right? Suppose if I make it subject VRG bar equal to VRM bar, carry this minus VMG onto LHS, that is plus or minus, it becomes positive, that is VRG equal to VRM plus VMG also. So VRG is the resultant of these two vectors. See, VRM and VMG collectively forming VRG. So VRG is the resultant of these two parent vectors. So we can form one more parallel line. See, VRG is the resultant of these two vectors, right? Now let us see one more example 5. That is example 5. So in this case, rain is falling at a slanted angle such that making an angle 53 with the horizontal. 53 with the horizontal line. 53 with the horizontal. This is what horizontal, right? Horizontal. So rain is going to fall like as that, making an angle 53 with the horizontal. This is what velocity of rain with respect to ground. What is the value? Means 50 kmph. Again 50 kmph. Right? But here a man is going to climbing up the inclined plane like that. See here theta is 37 degrees. Here man is walking up the inclined plane. Man M, who is walking at a rate of mg equal to 40 kmph. Right? See, this time observer is not at all walking or running on the horizontal floor. Here, observer is climbing up the inclined plane with the inclination is 30 degrees at a rate of 40 kmph and is going to observe this slantedly falling rain at 50 kmph as shown. Right? Now, how he would protect himself from the rain, let us see. Without getting wet, how he would protect himself from the rain. Right? Now, as usual, if I divide this vector into components, see, this is vertical component, this is horizontal component, right? What is the vertical component means? This is what adjacent component, this is opposite component. So opposite means 50 sine 53 degrees. 50 sine 53 degrees. That is 50 into sine 53 means sine 53. See somewhere here 53. Opposite side by hypotenuse. That is 4 by 5. 4 by 5 means 10 4 40 kmph. Right? So vertical component of VRG 40 kmph. Now what about horizontal component here? See, this is what horizontal component. That is 50 cos 53. That is 50 into cos 53 means cos 53 3 by 5 adjacent side by hypotenuse, that is 3 by 5 into 3 by 5, that is 30 kmph. Right? So what about VRG here? In vector notation, VRG bar equal to, see, x component along negative x-axis. So 30 into minus I cap, that is minus 30 I cap. Here y component also along negative y-axis. So 40 into minus j cap, that is minus 40 j cap. Right? Okay. Now here also velocity of man with respect to ground is, it's not one dimensional. It is lying in plane. So therefore, this also can be written. This also can be split up into two components. That is, right? See here. This is VMG. VMG means VMG. I'm writing somewhere here. VMG. That is 40 kmph. What is the angle? 37 degrees. So if I split this into two components, one is horizontal, another one is vertical here. What is component here? 40 cos 37. 40 cos 37. Right? That is 40 into cos 37 means cos 37. 4 by 5. Adjacent side by hypotenuse. That is what? 40 by 5. 8. 8 into 4. That is 32 kmph. Right? 32 kmph. Now what about vertical component here? This is what? Sine component. That is 40 sine 37. 40 sine 37. That is 40 into sine 37. Sine 37 opposite side by hypotenuse. That is 3 by 5. 3 by 5. 40 by 5 means 8. 8 3 is 24 kmph. 24 kmph, right? 24 kmph. Now what is the VMG in vector notation here means VMG equal to, therefore VMG bar equal to 32 into I cap plus 24 into j. See, this is what positive x direction means I cap. Here it is positive y direction means j cap. So 32 I cap plus 24 j cap. 24 j cap, right? Now VRM bar. Let us find VRM bar. VRM, velocity of rain with respect to man. That is crucial. Why? Because that only the direction in which he must hold his umbrella if he wants to keep the rain away. Okay, right? That is VRM bar equal to VR bar minus VM bar. That also can be written as VRG minus plus or minus VMG. That is VRG. What is VRG? This is what VRG. Somewhere here. See, this is what VRG. Minus 30i. Minus 30i minus 40j. Plus or minus minus. Plus or minus minus. VMG means this one. VMG 32i plus 24j. 24j. Right? That is minus 30 minus 32 means minus 62 I cap minus or plus minus minus 24j minus 40j minus 64j minus 40j minus 24, that is minus 64j. Again VRM finds two components as negative. See, minus j cap minus I cap means again VRM lies in third quadrant. Why? Because both components negative, means both unit vectors negative. So again this what third quadrant. VRM lies in third quadrant. Both are negative. So VRM bar. VRM bar. Right? If I take angle such that making an angle theta with lower vertical, you must hold his umbrella like that. Right? See, if this is theta, this one also theta. These two vertical opposite angles. So you must hold his umbrella such that making some angle theta with upper vertical. See, umbrella also holding along the same line as that of VRM, but opposite to VRM. Right? Now how to find theta here? VRM means minus 62i minus 64j. So this component, if I close like that, so this vertical component is 64. Adjacent component, that is this component, opposite component is 62. That is tan theta equal to opposite side by adjacent. Opposite, what is opposite here? 62. So tan theta equal to opposite side 62 by adjacent side 64. Right? Opposite side by adjacent side. Once again see here, minus 30i minus 32 minus 62i minus 64j minus 64j. Right? Minus 64j line. So that is tan theta opposite side by adjacent. That is 62 by 64. 62 by 64. That is 31 by 32. So theta equal to tan inverse of 31 by 32. So this is the direction in which you must hold his umbrella if you want to keep the rain away. Okay. Now let us see some best examples. Okay. Let's move on to discuss two wonderful sums. Here say, the first question, a man standing on road has to hold his umbrella at 30 degrees with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km/h. He finds that raindrops are hitting his head vertically. Find the speed of raindrops with respect to the road, means with respect to the ground. And second, with respect to the moving man, that is with respect to man. Right? See, from this data, here man is standing on the ground. On the road means on the ground. So this is what man, Vm, G, velocity man with respect to ground is 0. He is not at all moving in this case. But with respect to him, raindrops are falling like that. See, this is what vertical, this is horizontal here. He observes that as if rain falling at 30 degrees with vertical line. So velocity of rain with respect to man. So he hold his umbrella at 30 with the vertical like that. See, this is what umbrella. So if it is 30 degrees, this one also 30 degrees. See, he hold his umbrella along the same line of VRM but opposite to VRM. Right? Like that. So like that. He hold umbrella even though he is stationary or standing position without moving. He has to hold his umbrella at 30 with vertical. Why? Because with respect to himself, rain appears as it falls along this way. So this is the right position of the umbrella as per as given data, right? Like that. Such that making an angle 30 with vertical. 30 with vertical, right? Now, as per relative velocity equation, that is VRM bar equal to VR bar minus VM bar. That also can be written as VR means VRG with respect to ground, plus or minus VM means VMG bar. That is VRG bar not given, plus of minus minus, plus of minus minus VMG. What is VMG? 0. 0. That is in this case, especially in this case, VRM bar is equal to VRG bar. So as he is stationary, this might be velocity of rain with respect to ground also. With respect to ground. Why? Because of course even though it is velocity of rain with respect to man, that is relative velocity, this time that becomes equal to absolute velocity. Why? Because he is not at all moving. So therefore also can be written as V or G also. So VRM means VRG in this case. But here he decided to enjoy himself and throws his umbrella and walking on the running on the rainy day, right, without umbrella. He throws his umbrella and starts running at 10 kmph. He finds that raindrops are hitting vertically on his head, right? So this time, this is what velocity of man with respect to ground. That is what is equal to 10 kmph. 10 kmph, right? 10 kmph. So this time, when he starts running at 10 kmph, he observes as if rain drops hitting vertically down, like that. Vertically down like that. So velocity of rain with respect to man, right? So again, velocity of rain with respect to man means VR bar plus or minus VMG bar. See, VRM is the resultant of these two vectors, VRG and VMG. And VMG. Where is VRM? This is VRM in this case, alright? Now make it reverse VMG. So you will get minus VMG. Now where is the VRG? Even though he starts running from rest, there is no change of direction of relative velocity, direction of velocity of rain with respect to ground. So that is fixed. Even though he starts running, means he changes his state from rest to motion, but velocity of rain with respect to ground is constant. So this is what velocity of rain with respect to ground. That is constant as usual. So velocity of rain with respect to ground. Right? See, velocity of rain with respect to ground and minus of EMG collectively forming VRG. So this is the resultant of these two vectors. So minus VMG and VRG forms VRG. So this is the resultant of these two parent vectors. Now parallel to this side, close this side, parallel to this vector, close this side also. Right? So this is what parallelogram. Right? So VRM is the resultant of these two vectors. Of course, if you write like that, VRG equal to VRM plus VMG also. Here I am writing VRG also can be written as, carry this minus VMG onto LHS, that is VRM plus minus VMG becomes plus VMG. So VRG is the resultant of these two vectors. See, VRM and VMG forms VRG. So VRG is the resultant of these two, but VRM is the resultant of these two. These two vectors forming this one, these two vectors forming this one, like that. Okay. Now, what is this angle? 30 degrees. So in both cases, VRG is not at all changing. That is fixed with respect to ground, right? That is what absolute velocity of rain with respect to ground, fixed. Now the question is to find velocity of raindrops with respect to the road. With respect to the road means with respect to the ground. So I am taking sin 30 in this right angle triangle. Sin 30 equal to opposite side by hypotenuse. See, we are familiar with the opposite side. Why? Because this is 10. So therefore this one also 10. Opposite side. These two one and the same. So 10 here unknown. So sin 30 equal to opposite side by hypotenuse. Opposite means 10. That is VMG. By hypotenuse means VRG. VRG. That is sin 30 1 by 2 equal to VMG means 10 by VRG unknown. So VRG equal to 20 km. 20 km. This is what question number 1. That is A. Question A. Now question B. What is question B? We need to find velocity of raindrops with respect to moving man. Means VRM. So here VRM is question mark. VRM means see in this right angle triangle. This is what one side, this is what one more side, this is what hypotenuse. So in this right angle triangle, side equal to root over hypotenuse square minus side square. That is VRM equal to root over, see this side equal to root over hypotenuse square minus opposite square. That is VRG square minus hypotenuse square minus opposite square. Opposite means what? VMG. VMG square. Alright? That is what? Root over VRG square. What is VRG? 20. 20 square means 400. Minus VMG square. VMG means 10. 10 square means 100. That is root 300. That is VRM equal to velocity of rain with respect to moving man equal to root 300. Root 300 means 10 root 3 kmph. 10 root 3 kmph. That is the answer for second question. Okay. Finally, one more sum here. A man running on a horizontal road at 8 kmph finds the rain falling vertically. He increases his speed to 12 kmph and finds that the drops make an angle 30 with the vertical. Find the speed and direction of the rain with respect to road. Okay. Now see, from data, man is running on a horizontal road at 8 kmph. 8 kmph. So here is the man who is running at VMG, velocity of man with respect to ground. That is 8 kmph. Towards positive x-axis, for example, right? So he finds that rain falling vertically downwards. See, rain falling vertically downwards. This is what velocity of rain with respect to man. What is the velocity? Unknown, not given. So he finds with respect to horizontally running man, rain appears to fall vertically downwards, right? Now, as per relative equation, V or M bar equal to VR bar minus VM bar, right? That is V or G bar plus or minus VMG bar, okay? Right, VRM bar. Of course, VRG bar equal to VRG bar. If I make it subject VRG bar equal to, carry this minus VMG onto LHS, that is VRM bar plus VMG bar also, right? So VRG bar is the resultant of VRM and VMG. Of course, VRM is the resultant of VRG and minus VMG, right? See, this is what VRM, V or M, vertically downwards. So this is what VMG velocity of man with respect to ground, rightwards. Now on making reverse VMG, this becomes minus VMG. Now see, VRG is the resultant of VRM and VMG. This is what VRM, this is what VMG. Now resultant of these two is the VRG. So VRG must lie in between these two vectors. That is in fourth quadrant. This is what velocity of rain with respect to ground. See, VRG is the resultant of these two. So this is the resultant of these two. Okay. Of course, VRM is the resultant of these two. See here, previous step. VRM is the resultant of VRG and minus VMG. VRG minus VMG. Collectively forming VR. So parallel to this one side, parallel to this one side. So this is the resultant of these two. Right. Now as VRM is the resultant of these two, suppose this is P bar, this is Q bar, this is R bar. So angle between parent vectors theta, but angle between Q bar and R bar is the beta. I am taking this angle is beta. Right. This angle is beta. Okay. Right. Now on increasing speed to 12 kmph, speed of man increased from 8 kmph to 12 kmph. This time he finds that the drops making an angle 30 with the vertical. Right. Now this time, see, on increasing speed from 8 to 12, right? 8 to 12, like this is what VMG dash otherwise. That is equal to 12 kmph. 12 kmph, right? Now, what is the actual direction of VRG? There is no change in case of VRG, as usual. So this is what VRG as usual, right? In this case, when he speeds up from 8 kmph to 12 kmph, he finds that raindrops hitting him at an angle 30 with the vertical. At an angle 30 with the vertical means, see, this is what 30 with the vertical. So this might be the velocity of rain with respect to running man. Velocity of rain with respect to running man. Right? Okay. So make it reverse. VMG dash, this becomes minus VMG dash. That is 12 kmph. Right? So in this case also, VRM bar equal to VRG bar plus or minus VMG dash. So VRM dash becomes equal to VRG bar plus or minus VMG dash. Right? So parallel to this side. Right? Like that. Now what is this angle? This angle 30 degrees. So when he increased his speed from 8 to 12 kmph, right? So he must, as I told in the previous case, if velocity of man with respect to ground increases, right? He has to slant his umbrella far away from the vertical. Initially like that, right? Initially in previous case, he holds his umbrella vertically up. Why? Because he finds that the rain is falling vertically, right? But when he increases his speed from 8 kmph to 12 kmph, right? He has to slant his umbrella from vertical to 30 degrees, like from vertical to 30 degrees. That's what I told in the previous sum, right? If velocity of man increases, right, he must slant his umbrella furthermore from the vertical. Previously along vertical. Now he has to tilt his umbrella through 30 degrees like right? Now this is what position of umbrella like that. Okay. Now how to solve sum? What is the sum here? Find the speed and direction of the rain with respect to rod. Find the speed and direction of the rain with respect to rod. Find the speed of raindrops, right? Find the speed of raindrops. Now how to find means here, say this is what VRM dash. Suppose here it is O means origin. Now take one line which is perpendicular to VRM dash. So this is what VRM dash, perpendicular to this line. I am taking one more line. This is what perpendicular to PRM dash. Let be A. So here what I am writing means PRM dash is perpendicular to Y. Perpendicular to Y. See here, these two perpendiculars. Am I right? These two mutually perpendiculars. These two mutually perpendiculars. Am I right? Now, if it is 30 degrees, this must be 30 degrees. Am I right? This must be 30 degrees. Now, in previous case here, right? Now, what is VMG? VMG equal to 8 kmph. 8 kmph. Now, in previous case, I am writing here. What is that point means? The component of VRG along horizontal must be equal to 8. See, what is the component of VRG here? Along vertically downwards, VRG cos beta. Along positive x-axis, VRG sin beta. Am I right? Why? Because this is lying in fourth quadrant. We can resolve this vector into two components. One is vertically downwards, another one is horizontally rightwards. Am I right? So, what is the component along this way? VRG cos beta. This way, VRG sin beta. So, VRG sin beta. VRG sin beta. This vector finds its component VRG sin beta along VMG. So, VRG sin beta must be equal to 8. It implies sin beta can be written as 8 by VRG. VRG. This is what number 1. Collectively number 1. Number 1. Now from this diagram, as VRM dash is perpendicular to OA, here also along OA we can equate component of VRG and VMG dash. Am I right? Here point is equate components of VRG and VMG dash. VRG and VMG dash along OA. Right? So along OA we can add, means we can equate component of VRG and component of VMG dash, right? Now, what is the component of VRG? What is the component of VRG along OA? Means, see here, 30 degrees. Here it is beta from previous concept. Here, see, this is what beta. Why? Because this is VRG, this is also VRG. There is no change. So, beta, now what is the net angle here from here to there? Beta plus 30, or 30 plus beta. Now, what is the component of VRG along this direction? VRG cos 30 plus beta. What is other component along OA? Means VRG sin 30 plus beta. So, VRG sin 30 plus beta must be equal. So, VRG finds its component VRG sin 30 plus beta along OA. In the same direction, what is the component of VMG dash? Means 12 cos 30. See, this is what 12 are, 12. Otherwise, VMG dash. Now, what is its component along OA? Means VMG dash cos 30. VMG dash cos 30. Right? So, simply what we did here means we equated components of VRG and component of VMG dash along OA. That's all. Now I am rubbing off here. To proceed further, I am rubbing here. Right. On extending on extending what is here VRG. In first expression, what is here VRG? VRG sin beta equal to 8. Am I right? VRG sin beta equal to 8. This is what number 1. Otherwise, sin beta equal to 8 by VRG. This is what number 1. Collectively number 1. Right? Number 1. Now see, VRG means what? VRG means 8 by sin beta. Right? Sorry. VRG equal 8 by sin beta. Sin beta. Now VRG means we can write 8 by sin beta. VRG means 8 by sin beta into sin 30 plus beta means sin of A plus B form. Sin of A plus B means sin A cos B plus cos A sin. That is sin A means 30. Sin A cos B means cos beta plus cos A. Cos A means cos 30 into sin beta. Sin A cos B plus cos A sin B. That is equal to VMG dash. VMG dash means 12. 12 into cos 30 means root 3 by 2. Root 3 by 2. That is 8 by sin beta into sin 30 1 by 2 into cos beta plus cos 30 root 3 by 2 into sin beta equal 12 by 2 means 6 root 3. Am I right? 6 root 3. That is 8 by 2 means 4. Cos beta by sin beta means cot beta plus 8 by 2 means 4 root 3 sin beta by sin beta 1 equal to 6 root 3. Right? So 4 cot beta equal to 6 root 3 minus 4 root 3. That is 2 root 3. Right? That is cot beta equal to root 3 by 2. Means beta equal to cot inverse root 3 by 2. So this is what the direction of velocity of rain means beta. See, this is what beta. Velocity of rain with respect to ground. So here actually rain is falling at an angle beta. Beta means cot inverse root 3 by 2 with the vertical. This is the actual direction of rain with respect to ground. That is what one question is over. Now what is other question? Find the speed of rain with respect to road. Means velocity of rain with respect to ground. Velocity of rain with respect to ground means here only there. What is that? VRG equal 8 by sin beta. 8 by sin beta, right? 8 by sin beta. 8 by sin beta. Now cot beta equal root 3 by 2. Try to find other side here. Beta from right angle triangle. Cot beta equal to adjacent side by opposite. Adjacent side by opposite. 2. Now what about hypotenuse means root over a square plus b square. That is root over 3 plus 4, root 7. Hypotenuse, right? Now one implies what is VRG? VRG equal to velocity of rain with respect to ground, that equal to 8 by sin beta. 8 by sin beta, that is 8 by sin beta from this right angle triangle. Sin beta means opposite side by hypotenuse, that is 2 by root 7. 2 by root 7. Right, that is 8 by 2 means 4. 1 by root 7 means into root 7. That is VRG equal to 4 root 7 kmph. This is what actual velocity of rain with respect to ground. That is absolute velocity of rain with respect to ground. Now what is the direction of that absolute velocity of rain with respect to ground means beta. What is that beta? Cot inverse root 3 by 2. Okay friends, with this I conclude. Thank you. Have a nice day.